Hi everyone, in this video we're gonna solve a very easiest problem ever known and asked in the IMO International Mathematical Olympiad. So what we're gonna prove? We're gonna prove that 21n plus 4 over 14n plus 3 is irreducible for every natural number n. So I will prove it by contradiction. Proof by contradiction. As I need to prove that this fraction is irreducible, so I'm gonna let that 21n plus 4 over 14n plus 3 is reducible. If it is a reducible fraction, then there must be a greatest common factor of 14n plus 3 and 21n plus 4. So here I let that p is the greatest common factor of 14n plus 3 and 21n plus 4. So if p is a common factor of greatest common factor of 14n plus 3 and 21n plus 4, so I can write it as 21n plus 4 is congruent to 0 mod p. Similarly, 14n plus 3 is congruent to 0 mod p. So if 21n plus 4 is congruent to 0 mod p, then if I multiply it with any number, here I gonna multiply it with 2. If I multiply this equation 1, this equation 2, if I multiply this equation 1 with 2, it will be 42n plus 8 is congruent to 0 mod p. And if I multiply the equation 2 with 3, it will be 42n plus 9 is congruent to 0 mod p. Now I'm gonna subtracting the second equation from the first equation. If I subtract the second, this is the second one equation, this is the first one equation. If I subtract the second equation from the first, I got 1 is congruent to 0 mod p. That is totally absurd. So my supposition that I suppose that 21n plus 4 over 14n plus 3 is irreducible is totally wrong. So hence it's proved that 21n plus 4 over 14n plus 3 is irreducible.